The simplest alkene is that which has two carbon atoms and it is known as ethene. This is the molecular structure. As you all can see, there's a double bond between the two carbon atoms. And if you look at each carbon atom, it forms two bonds with its neighboring carbon atom, and then the other two bonds are formed with hydrogen. This is the molecular formula C2H4, and here is a dot and cross diagram of ethene. Now, as you all can see, between these two carbon atoms, there's a higher density of electrons because it is a double bond. And one of these double bonds is weak. Therefore, alkenes are much reactive than alkanes. This is the common formula of alkene, CnH2n. Polymers can be produced by the derivatives of ethene. Now let's try to understand what polymers are. From plastic goods to fabrics to rubber products, the chemical nature of these materials are similar at molecular level. They are all large molecules arranged in the form of a long chain. These are known as polymers. Large molecules formed by the joining of a large number of small molecules with one another are known as polymers. Monomers are small molecules with relatively low molecular mass. They link together by a process known as polymerization to produce a large molecule called polymer. Polymers have very high molar mass. Now let's look at some of the most common polymers in use. Polythene, also known as polyethylene or polyethylene, is a very common polymer used in the production of polythene and plastic materials. It is made up of large number of ethene molecules polymerizing to form a large molecule or macromolecule. The double bond in the ethene molecule is broken to form bonds with one another during the process of polymerization. Ethene molecule is the monomer and the polythene formed is the polymer. Keep in mind, only a portion of the polymer is depicted in the diagram. And these two incomplete lines indicate that this is just a portion of the large polymer. Once the polymer is formed, it would have a basic structural unit that repeats over and over to form a long chain. I think you can identify that in this picture. That structural unit is known as repeating unit. As you can see, the double bond in the monomer is broken down to combine or link with many monomer molecules and form the polymer, and finally the polymer would have a structural unit that repeats over and over again to form a long chain, and that structural unit is known as the repeating unit. Summary of the polymerization process can be depicted this way. N number of ethene molecules combine to form a polymer with n number of repeating units. The n here represents the number of monomers that link together to form the polymer. So you should understand the number of monomers that link together to form the polymer is equal to the number of repeating units in the polymer. Here are the definitions of polymers, monomers, and repeating unit. Polymers are very large molecules formed from linking together a large number of small molecules. Monomers are small molecules contributing to form polymers. Repeating unit is the basic structural units contained in a polymer. Polychloroethene is another polymer made out of a derivative of ethene. When n number of chloroethene polymerize, they form the compound polychloroethene or polyvinyl chloride. Polytetrafluoroethene or Teflon. When the derivative of ethene, tetrafluoroethene, polymerizes, it forms the polymer polytetrafluoroethene. Polyvinyl chloride is also known as PVC. You would all know that it is used in making water pipes, and it has certain special properties which makes it useful in making these products. It is resistant to fire, it is an electrical insulator, and it is impervious to water and light. Polytetrafluoroethene or Teflon is used in making non-stick cooking pans, and it has the special properties of being resistant to heat, and it is also an electrical insulator. Polyethylene is used in most of the plastic bottles and polythene bags that we use. The special properties of polyethylene are: it is an electrical insulator, it is impervious to water and air, and it is light, which means it's not heavy, and can withstand tensions, and it is much durable. Assignment 2. Write the balanced chemical equation for the complete combustion of butane. Assignment 3. Fill the following table. Polymers can be classified based on their origin and based on their structure. Based on their structure, polymers can be classified as linear and branched. Branched polymers can be further classified as polymers with crosslinks and polymers with side chains. Polymers can be classified based on their origins as natural polymers and artificial polymers. All that we discussed so far are artificial polymers: polythene, polychloroethene, Teflon, and then there's polyester, nylon, and terylene, which are synthetic fibers used to produce garments. And then polystyrene, which is commonly known as rigiform. And bakelite is the first plastic made from synthetic compounds. Now let's look at natural polymers. The biomolecules that you learned in grade 10 are all natural polymers: proteins, DNA, starch, cellulose, and RNA. And rubber is also a natural fiber. There is synthetic rubber that is produced as well, but it has a different chemical structure. Rubber is a natural polymer, and this is the summary of the polymerization process. Rubber is made up from the monomer called as isoprene. Now, if you look at its monomer, it has two double bonds, and then it polymerizes to form rubber. And in the polymer, the repeating unit would have the double bond between the two central carbon atoms. The double bonds in the monomer are broken down to link with each other and polymerize. Here is the repeating unit, and this is the polymer formed. Classification of polymers based on structures. As you can see, most of the polymers that we discussed so far have linear structures. They are linear chains, but not all polymers are linear. By joining polymer molecules laterally to the principal chain of the linear polymers, branch polymers are produced. The polymers in which the linear chains are cross-linked are known as polymers with crosslinks. Polymers where side chains are attached to the principal linear chain are known as polymers with side chains. Now let's look at a polymer with crosslinks. Rubber is naturally elastic, but certain applications of rubber require it to be hard and less elastic. Vulcanization is the process in which rubber is made hard while decreasing its elasticity, thereby improving its physical properties. Vulcanization process includes heating of the rubber latex to a high temperature with sulfur. Vulcanization forms crosslinks between the linear chains to form a cross-linked polymer. Rubber is white in color, but most rubber products are black because of the carbon black filler added. Today, we use artificial polymers as substitutes for many purposes. Here are some reasons why polymers are considered very important to us. Polymers can be synthesized with the required characteristics needed for our purpose. They are much easy to use. And polymers can be produced in various shapes, sizes, and thicknesses. And also, different kinds of colorful polymers can be produced. And polymers are much cheaper compared to their alternatives of glass products and wooden products. Along with these advantages of polymers, there are certain major drawbacks of using polymers. Polymers are non-biodegradable, therefore, once we use them, they get accumulated in the environment, thereby polluting it. And combustion of artificial polymers release poisonous gases. Combustion of polymers with only carbon and hydrogen will produce carbon dioxide. Carbon dioxide is a greenhouse gas which contributes to the increase of global warming. Polymers with nitrogen and sulfur would produce toxic gases such as sulfur dioxides and oxides of nitrogen. Polymers with hydrogen would produce corrosive gases such as hydrogen fluoride and hydrogen chloride that can form acid when in contact with moisture in eyes, skin, and lungs. And also, fuels, when they are burned incompletely, they release carbon monoxide, which is a toxic gas. Artificial polymers such as nylon, terylene, and polyester do not absorb sweat and cause discomfort to the body. Therefore, these polymers are now made combining with natural fibers such as cotton and wool, and garments are produced from them. Biodegradable, water-soluble, and photodegradable polymers are synthesized now, and they are becoming popular in the market because of their eco-friendly nature.